From skyscrapers to bridges, from household appliances to cars and everything in between. Thanks to its legendary strength, steel can be trusted to be the backbone of industry. But how do you turn one of Earth's most abundant resources into a reliable building block? Steel is made from either iron ore or scrap metal. In this operation, it's scrap that will be recycled. Using a 10-ton electromagnet, crushed car bodies, electrical appliances, cans and other steel scraps are gathered up. This powerful magnet is able to lift 5 tons of metal. About 80% of this scrap will be transformed into bars of steel. This metal is then dumped into a basket which alone weighs 32 tons. The basket can hold up to a staggering 60 tons of metal, which is going to be turned into molten metal. This furnace reaches a temperature of 1,650 degrees centigrade, hot enough to liquefy just about anything. The furnace is heated by 3 electrodes and by 4 natural gas burners. The contents of the basket are dumped into the furnace. The pieces of metal come into contact with liquefied steel, and an aeration system draws out the smoke that's produced. At this intense heat, the 60 tons of metal will melt in around 60 minutes. This molten mix is composed of impurities which rise to the surface when the metal becomes liquefied. At this stage, a workman draws a sample of steel to determine its chemical makeup. Next, a lance blows oxygen into the molten steel, which reduces its carbon content, homogenizing the mix and speeding up the process. A ladle is positioned beneath the furnace. The molten steel will be transferred from the furnace into this ladle. The molten steel easily pours into the ladle. The ladle weighs 55 tons and holds 115 tons of molten steel, and an overhead crane capable of lifting 180 tons hoists its cargo. Additives are introduced in order to obtain the correct steel tone. Here the electrodes are taken out of the furnace ladle. A workman now opens the pouring nozzles of the distributor. The molten steel runs into molds. It quickly cools and begins to harden. Steel billets are produced in lengths varying between 4.5 and 10.6 meters. The billets are then cut into the desired length with a natural gas torch. A pouring identification number is marked on them with a wax crayon. The flattening of the billets remains to be done. Before flattening begins, billets are placed in the furnace to be reheated for 2 hours at 1,095 degrees centigrade. Water jets cool the billet ejector. The billets are placed on the flattener, where powerful rollers compress them. This operation gives the billets the required shape and size. Water-cooled rollers crush the billets. Some billets go from a thickness of 12 centimeters down to 14 millimeters, while others reduce from 15 centimeters down to 19 millimeters. At the end of the production, bars move along at a speed reaching 35 kilometers per hour. Once they've reached their required dimensions, the bars must be cooled. This cooling bed allows the steel bars to cool uniformly. A total of some 400,000 tons of steel bars are made at this plant each year.